All right, this is going to be a short video. We've already looked at solving one-step inequalities by using multiplication. We've already looked at solving one-step inequalities by using division. However, there's one very specific type of problem that's going to come up, and we need to be able to deal with that. And so we're going to look at some examples. I want you to really remember that this doesn't happen all the time, but when it does come up, we need to be able to deal with it. And it's a kind of a unique situation. So I have two problems here. They look very similar. We're going to solve the inequality and graph the solutions. We've got negative 50 is greater than or equal to 5q. So if we're going to solve for q, we're going to do the inverse operation. We're going to divide both sides by 5. 5 divided by 5 is 1q left over. And we've got negative 50 divided by 5, negative 10. So negative 10 is greater than or equal to q. We'll graph those problems here. So we've got negative 10 goes in the middle. Remember what we need to count in the correct way. Negative 10, negative 9, negative 8. We're getting closer to 0 as we go to the right. And we're getting further away from 0 as we go to the left, because negatives go in the opposite direction of the positives. All right. This says that negative 10 is greater than or equal to q. So what numbers are greater than or equal, or excuse me, negative 10 is greater than or equal to q. So what numbers would work for q? Negative 10 is not greater than or equal to negative 11. That would be wrong. Negative 10 is actually, sorry, it's end of the day. You can hear the bell there. Negative 10 is going to be greater than or equal to q. So negative 10 would be greater than or equal to negative 11. Would not work for this one. This would be wrong. That negative 10 is not greater than negative 9. What I had before, that negative 11 is going to be less than negative 10. Negative 10 is going to be greater than or equal to negative 11. Does work. And so all the numbers that are less than negative 10 are going to be going in this direction. So we're going to have that negative 11 is less than or equal to negative 10. And so that does work. And then we're going to close in that circle. Close in that circle, because negative 10 could be a solution. And again, that question that I kind of fumbled over here a second ago was that what numbers would work? Well, what numbers are less than negative 10? What numbers are negative 10 greater than? Negative 10 is greater than negative 11, it's greater than negative 12, and it's greater than negative 13, etc. We've got that solved. Okay, that was the other notes. Now we've got the new notes, the new weird situations. So it looks very similar. We're going to solve it the same way. We're going to divide both sides by negative 5, divide both sides by negative 5, and we're going to get 10 and q. So let's find a solution to this. 10 is greater than or equal to some number q. How about 0? 10 is greater than or equal to 0. I would say that's true. That 0 could be a solution to this inequality. 10 is greater than or equal to 0. That's true. Let's look back at the original problem. Negative 50 greater than or equal to negative 5q. So if I plug 0 back in, if I'm saying 0 could be a solution, that means that negative 50 is greater than or equal to negative 5 times 0. That means that negative 50 is greater than or equal to 0. That's wrong. Let's try another one. Okay, so I'm going to erase this. Let's try a different one. What's another number that's less than 10? I don't know. How about 2? 2 is less than 10, so 10 is greater than 2. So negative 50 then is greater than or equal to negative 5 times 2. Let's see, negative 50 greater than or equal to negative 10. No, that's wrong as well. Negative 10 is closer to 0 than negative 50. So negative 10 is actually greater than negative 50. Every answer we're getting is wrong when we plug it back into the problem. However, we solved it correctly. We divided both sides by negative 5. That's all good. So the only thing that's wrong is this. If it was flipped around, then it'd be correct. Negative 10 is greater than or equal to negative 50. In fact, if we go back to my original answer here, if I flip this around, any number greater than 10, not any number less than 10, but any number greater than 10 will work. Let's see how that ends up going. So let's pick a number greater than 10. How about 11? If instead of 2 here, let's say I substitute Let's say I substitute 11 into the problem. Now, negative 50, and I've got a new symbol. Negative 5 times 11, negative 5 times 11, that's negative 55. And that's true. Negative 50 is less than or equal to negative 55. That works. In fact, any number that you choose greater than 10 will actually give you a correct solution. And what happens is, in these unique situations, if you are multiplying or dividing by a negative number, you need to take that symbol right here and you need to flip it around. It needs to be turned backwards if you're multiplying or dividing by a negative. And the reason we do that is because it doesn't work otherwise. It will not work unless we flip that around. And so when you're dividing by a negative or when you're multiplying by a negative, you need to turn that symbol backwards. And now we can graph it. So 10 is less than or equal to Q. I'm going to put 10. I'm going to put 11, 12, 9, 8. So any number greater than 10 would be a solution to this inequality. So it is going to be a slightly different solution than what we would have had if we left it alone. And that's, we did some examples to kind of show that it really doesn't work unless you flip that symbol over. But what you need to remember is any time that you multiply or divide by a negative, you flip the symbol around. Let's look at a couple examples here. Maybe pause it, try solving. Solve it just the way you normally would, and then flip that symbol over, and we'll see if you get the same result that I do. Okay, I'm assuming you paused it, tried it on your own. These are only 3 questions we're going to do here. So we've got negative 12x is greater than 84. So if I divide both sides by negative 12 to get x by itself, I'm dividing by a negative number. If I'm dividing or multiplying by a negative number, I get that x, and let's see, 84 and 12, is that 7? Negative 7? Is that right? Yeah, negative 7. Now, if I left the symbol alone, and this is wrong, so if you wrote it the other way, then don't fix it. But if I left it alone, that means that any number greater than negative 7 will work. So if I pick a number greater than 7, say 0, 0 is greater than negative 7. If x was 0, negative 12 times 0, which is 0, negative 12 times 0, is not greater than 84. 0 is not greater than 84. This would be wrong. So we need to flip that around. So let me do that. So that's wrong. That doesn't work. 0 is definitely not greater than 84. However, if I put the symbol the other way, any number less than negative 7, how about say, negative 10. Negative 10 is less than negative 7. Negative 12 times negative 10 is 120, and 120 is greater than 84. So it works. And so the final solution then is that x is less than negative 7. We're going to graph those solutions, negative 7, negative 6, negative 5, negative 8, negative 9. X is less than negative 7. Those numbers are less than negative 7. And negative 7 is not included in the solution because negative 7 is not equal. It's x is less than negative 7, not equal to. Okay, let's try the next one. So I'm going to solve it as if I were normally solving an equation or an inequality. Opposite divide is times, both sides by negative 3. Since I'm multiplying by a negative, I'm going to need to turn that symbol around. I get x by itself, 24. X is less than or equal to 24. 24 is greater than or equal to x. So 24, 25, 26. I'll let you try one on your own and see if, try an example, kind of like I did before, and prove to yourself that it works. But at this point, I'm just going to go ahead and graph it. X is less than 24. So these numbers are less than 24. X could be equal to 24. So we're going to fill in that circle. And the last one, 8x less than negative 24. I'm going to divide both sides by 8. Now, I am dividing by a positive 8. I'm not dividing by a negative number. Doesn't matter that 24 is negative. Does not matter that 24 is negative. We don't care. If you are multiplying or dividing by a negative number, you flip the symbol around. I'm dividing by a positive number. I'm dividing by a positive 8. So we're going to leave it alone. Negative 24 divided by 8 is negative 3. It doesn't matter if I have a negative answer or not. I divided by a positive number. Just to double check, let's see what happens. Pick a number less than negative 3. I'm going to go with negative 10 again because that's easy to use. Negative 10 is less than negative 3. 8 times negative 10. 8 times negative 10 is negative 80. Negative 80 is less than negative 24. So it does work. That negative 80 is less than negative 24. And so what I wrote down here is correct. I checked it. It does work. And so I'm going to graph those solutions. X is less than negative 3, so I put my solution in the middle. I make sure that with negatives, I'm counting correctly. I'm moving closer to 0 to the right, further away from 0 to the left. X is less than negative 3. Negative 5 is less than negative 3. And X cannot equal negative 3. So again, we're solving the same way we were solving in the last notes. The only difference is that we are flipping the symbol around if you're multiplying or dividing by a negative, and only if you're multiplying or dividing with a negative number. So try these three on page S7, 41, 43, 45. I printed them here, but you can certainly go in the book and see those as well. Solve for the variable. Be careful only if you're multiplying or dividing by a negative.